What we're going to do now is we're going to walk through a case study illustrating how to program Java threads. And that will give us something to refer back to as we start diving down into each of the different features of Java threads in upcoming lessons. This particular case study can be obtained at my GitHub repository in this link. And there's actually a whole slew of these different examples. This is the first one we'll take a look at. It's very simple. So what is this app? And I'll actually run the app for you in a minute. This app concurrently computes the greatest common divisor of pairs of randomly generated numbers. And as you probably know, GCD is the largest integer that divides two integers without a remainder. So here's basically the overall structure of the app. As you can see, we're going to have a couple of different classes. We have this thing called the lifecycle logging activity, which is just there to show you what Android's doing under the hood if you're really curious. You can look at it in the logcat feature in Android. There's also this main activity. This is where most of the Android code resides, with a little bit of driver code to do interesting things. And then we have something called Gcd Thread, which is a class that inherits from Thread and overrides its run method. And then we also have Gcd Runnable, and that's a different way of getting something for a thread to do, which involves implementing the runnable interface and then making sure that that gets passed to the thread constructor before we start running the thread. So we're going to take a look at these two implementations of threading in just a moment, but there's two of them, and I want you to understand the most common ways of structuring threads. But first, we'll show how to build and run the app, and then we can go ahead and take a look at how the code works. So let's go ahead and go to this link here. And as luck would have it, I pre-set up my Android Studio to include what we need to show here. So this is actually running the emulator. And you can see we're going to click on a couple buttons. We have Run Runnable, Run Thread, and Run Thread Runnable. So Run Runnable goes ahead and generates these random GCD numbers and computes the GCD using this runnable approach. Whoops. Run Thread does the same thing, but with a thread as opposed to a runnable. And then Run Thread Runnable is yet another variation, and we'll take a look at that as well. So that's just to show you what it's doing. Not the world's most exciting app, mind you, but it's kind of fun. So let's go ahead and take a quick look at this code. So here's the app. If you load it into Android Studio, it'll basically configure itself properly, hopefully, if you set up Android Studio properly. And you can take a look here. This is the main activity. This is where it's the entry point into an Android app. So when you run this app, that's where Android will start. It's got basically some widgets for keeping track of scroll view and text view. I'm not really going to talk about that stuff because that's outside the scope of the course. But here are the methods that get called back. Remember, we clicked on the Run Runnable menu item or selection on the screen, and we had the Run Thread. When those items are selected, these are the methods that get called. And so what Run Runnable does, as you can see, is it goes ahead and it creates a new entity called Gcd Runnable, passing in this object. Then it makes a new thread, passing in the runnable command as the parameter, and then it starts the thread. So those are the things that happen there. Let's go take a look at Gcd Runnable. Gcd Runnable, as you can see, is just a class that extends the random class. That means we implement and inherit the random number generation capabilities, and it implements the runnable interface. And it keeps track of its activity because it wants to be able to print to the screen. We've got ourselves a couple of fields, one called max iterations, one called max print iterations. So this program is going to run for 10 million iterations, and every million of those, it's going to print out a diagnostic just indicating what the current value is, just so you can see what it's doing. I didn't want to print 10 million values. That would take a long time. So here's the run hook method. Remember, when we start the thread, if we come back over here and we look at the main activity, when start is called on the thread, that will end up causing the run method to be called. Very important to remember. Do not call run yourself. You never call run directly. You always start the thread after giving it something to do, in this case, giving it a runnable. And then the thread creates the stack, as we'll talk about later in a different lesson, and then it gives control so it can go ahead and do the work. And the run hook method is what does the work. So what run does here, it prints out some diagnostics. and then it goes into an iteration for this 10 million times, generates random integers using the random number generator that we inherited. And then down here, every 1 million iterations, so basically 10 times, it's going to print out the results of calling the compute GCD. Okay, so here's compute GCD, not very exciting. It's just a recursive implementation of Euclid's algorithm to compute the GCD. Okay, so that is the runnable variant of this stuff. Here is the run thread variant, kind of a little bit different, interesting in its own way. In this case, we're going to make a new instance of something called GCD thread. We'll look at that in a second. And once we make ourselves a new GCD thread object, we then call it setActivity method to set the activity, and we call its random setter method to set the random number generator. And then we start the thread. So this particular way of doing things, where you take an object and then you chain method calls on it, is called the fluent interface pattern. And you'll see a lot of that in modern Java, especially if you start programming with modern Java like Java streams or reactive streams. So let's go ahead and take a look at GCD thread. Here's GCD thread. You can see that it just extends threads. Remember the previous implementation, which was GCD Runnable, didn't extend thread. Instead, what GCD Runnable did was it implemented Runnable and extended random. In this case, we extend thread. So we make our own random number generator because we're not actually extending anything this time. Same number of iterations and print iterations. And here's the run hook method. It looks very similar to the one we had before. The main difference being that we have to access the random number generator through its field because we didn't extend from random, and therefore we have to get it a slightly different way. The loop otherwise is identical. Here's the stuff that's kind of interesting. So here are the two setter methods, and they're actually setter-getter methods in a way to use the fluent interface pattern. You can see that if you want to set the random number generator, you pass the random number generator in here, we set it, and we return this, and that way we can chain these things together. Same thing with set activity. We set the activity, we return this. So we can chain those various calls together as you see here. And then the third and final way to run the threads, we call run thread and runnable. It's going to create a list of threads, and then we're going to add 2 items to the list. You can see here we first add the GCD thread, and second we add the GCD Runnable, which is passed as a constructor to the thread. And then we say, for each of these elements in this list, call the start method. And this is a little bit, this is modern Java syntax. So what you can see here is that we're using the for each method, which came along with Java 8, and we're using something called thread : start, which is what's known as a method reference. And that's very much like a pointer to member function or pointer to static member function in C++, if that rings a bell with you. So after we start those threads, we then make ourselves a new waiter thread, just for fun. And this waiter thread is going to go through, the code we give to the waiter thread is going to iterate through every thread in the thread list, joining with the thread. So this is another example of a barrier synchronizer. This is also using a very clever, maybe too clever, feature in Java called exception laundering. And this is what it's doing. The join method in Java requires a try-catch block because it's got what's called a checked exception. And so what we're doing here is we're writing a little adapter function that converts something that takes a checked exception into something that throws it as a runtime exception or an unchecked exception, a dynamic exception. So the exception is still being caught. It's just being caught at runtime rather than having to be explicitly caught at compile time. It is being caught at compile time. It's just being caught in the adapter. Anyway, don't worry too much about that yet. It's just a really cool little feature. Okay, so that is basically, oh, and I should also show you this. This is kind of cool. This is the code that is used to print things in Android. And we do this by making a runnable command that will append the string to print to the text view and then move the focus down by what we just added to the text view. And here we're going to pass the command, which is called from a background thread to have the actual modification to the user interface done through the user interface thread, because you can only print to the console or the screen in the user interface thread in Android, but we're running all these things in the background. So this is a very cool little technique you can use. Again, it's a little bit off the scope of the course, but it shows you how you can pass things from one thread context to another. Okay, so that is basically our example that we're looking at here today. We'll take a deeper dive through all these features as we go through other parts of the lessons.